Good day, folks. Welcome to Price Mind Academy, where we bring brilliance to every lesson. I want us to look at the air pressure versus time graph today, okay? Yes. So it says now, the siren of a police car which is traveling at a constant speed along a straight horizontal road emits now waves of constant frequency, okay? Detector P is placed inside the police car and detector Q is placed next to the road at a certain distance away from the car. Okay, so detector P is placed, it is inside the car. So detector P detects the what? The frequency of the sound. Okay, this one, since well it is placed inside, it detects frequency of the sound. Detector Q is placed next to the road, distance away from. This one will detect the frequency of the listener. Very, very key. Very, very key information. The two detectors recorded a change in the air pressure reading caused by the sound waves emitted by the siren as a function of time. The graphs below were obtained from the results. Graph A, air pressure versus time recorded by P. Remember this one? Recorded by P will tell us about the what? The frequency of the sound. Because detector P, it is inside the what? The car. So if the car emits the sound like that, detector P will hear the same frequency. The frequency will not have different intensity as compared to this one, okay? Yes. As compared to that one, okay? Yes. So now let us be in a position of understanding if it is moving away or towards. Emits, okay, detector Q is placed next to the road at a certain distance away from the car. Okay, I understand it is at a certain distance away from the car, but the question is it moving away or it is moving towards? Maybe they will tell us. This will record now the frequency of the listener, like that. Okay. So now different paths are shown above for the same sound wave, blah, blah, blah. What phenomena is illustrated by the two detected, blah, blah, blah. This is Doppler effect. They tell us now the police car is moving away from Q. Very, very important. This is very, very important information. Use the graph and give a reason why it can be confirmed that the police car is moving away from the detector Q. Yes. Why can we prove that? Can you see that the wavelength here, it is like that, okay? But here, can you see the wavelength becomes longer? Can you see the wavelength becomes longer? Okay. Remember, if it is moving away, the wavelength, that's what becomes longer, but the frequency becomes lower. I guess, can you see here the complete wavelength it is 17, but here the complete wavelength it is 18. So now how can we prove that? Use the graph, why it can be confirmed. Now we can say the wavelength, or you can say wavelength in weight increased like that. The wavelength increased like that. Calculate the frequency of the sound wave recorded by detector P. Recorded by detector P. Detector P, where is detector P? Detector P, guy, man. Here is detector P. So we want the frequency. Remember, how do you calculate frequency from this graph? You say frequency is going to be equal to 1 divided by T. But remember, it needs to be the time after one complete wavelength. What is one complete wavelength? It is half and half. It is one complete wavelength. So it means the time, it is how much? It is 17. So it means now I can say, okay, this is what I want you to take note of is that it is going to be 1 divided by 17, but the time should be in times 10 to the power of negative 4 times 10 to the power of negative 4. Therefore, let us see the frequency that we get. And I told you, P will record the frequency of the sound, okay? Because the detector is placed inside, okay? So if it is placed inside, it means it records the frequency of the sound, which does not change because it's still inside. Okay, it is not moving away from that detector or towards. It is within it. Okay, yes. Then I get something like 588,24 hertz. Okay, this is for 10.3, where I calculated the frequency of the sound wave recorded by by detector P. Okay. And I repeat, detector P records the frequency of the sound, and detector Q records the frequency of the listener. Okay. Use the information in the graph to calculate the speed of the police car. Take the speed of the sound in air as 340. Now, what you need to do first is calculate the frequency of the listener by saying 1 divided by time. Frequency of the listener, it is 1 divided by time. Now, 1 divided by time. Time taken to complete the full wavelength. It is how much time taken to complete the full wave. It is 18. And do you agree with me that since while it is moving away, the frequency of the listener, I'm expecting it to be less than the frequency of the sound. Why? It is moving away. Let's see if that will be the case. 1 divided by 18 times 10 to the power of negative 4. How much does it give me? It gives me that the frequency of the listener is something like, let me see that, 18. I get something like 555.56 hertz. Is it less than that one? Yes, this one was 588.24. Very, very good. Therefore, I can come to my formula and say frequency of the listener is equal to V plus or minus velocity of the listener, V plus or minus velocity of the sound, Fs. Now, is it moving towards or away? It is moving towards away. So frequency of the listener, it is 555.56. It is equal to 340. Did I say take 340? Yes. Therefore, it is moving away. If it is moving away, it is minus. The listener is at stationary. It is placed along the road. Velocity it is 340 plus Vs multiplied by the frequency of the sound, which is 588 point mang, 588 point mang, 0.24. 24 like that. Then you do a mathematical gymnastics. Say 555.56 divided by 588.24. You'll get something like 0.944444, right? 0.944444 like that. But you can leave it as 17 divided by 18. Then I want you to multiply. Okay, let me say okay, here we'll be left with 340 divided by 340 plus Vs. Then take this and multiply it to the other side, okay? Say 17 divided by, do not do cross multiply. Say 17 divided by 18 multiplied by 340. You will get an answer of 321.111 blah, blah, blah. Plus 17 divided by 18. 17 divided by 18 multiplied by Vs. Multiply by 1, which is the same as multiply by 1. You'll get something like 0.9444, which is 94. Okay, let's add another 4. It is equal to, so this is Vs. It is equal to 340. Then please do your mathematics very well, and I'll just continue. 340 minus 321, sorry, yes, 321, 11. Then divide by 0.944, like that. I get a velocity of 20.01 meters per second. If you avoid rounding off, you might maybe get an answer of 20 exactly. Let me try to do that quickly. 340 multiplied by 588.24 divide by 555.56. Then yeah, you might get 20 straight. Okay, so yeah, that is it for this question. Can it? Yes. Now the first mark will be you coming from here, substituting this one. Okay. Then here, the formula. Then now the answer. How many marks is that? 2, 4, 2, 4, 1. I go. Oh, how do they mark this formula then? Or is the frequency of the sound, frequency of the listener, then numerator and denominator, final answer, and all of that. So yeah, that is that for 6 marks. I hope you understand the graph here. I also made a video where I explained when I did Doppler effect video, I explained Doppler and all of that, and I explained the graphs of Doppler. I explained this graph also. Okay, so if you are not so sure, please rewind back to the video. Okay, so thank you very much for joining me. I hope you enjoyed the video. Thank you.